This presentation uses the NTSB All Accident Incident Dataset. I'm going to provide an overview of these data, a process for identifying variables and taking a random sample, and what to do when the assumptions are not met. When you open the dataset, it may look a little bit different than the way I have it set up here. All I've done is to move the columns of data that I'm most interested in toward the left side of the screen so that I have ready access to them. This is a large data set. There are 76,024 columns of data. There are over 2.5 million cells of data. So this is a fairly large population data set that goes back to 1982, and I believe the last date for data here is December 31st, 2013. I am, for this presentation, looking just at accidents, and I'm wanting to know if there is an association between certain categories of the purpose of flight and the broad phase of flight. So before we get started, we need to see, are there enough data to analyze? So I'm going to highlight these first three columns of data, and I'm using Excel for Mac. And so I'm going to go to Data and select Pivot Table. And we're going to use the random number as a way to count things. So I'm not summing the random numbers up or doing any kind of arithmetic operations on them. And then we're going to put purpose of flight and broad phase of flight as our variables. So when I look at these data, I am mostly interested in terms of the purpose of flight, business and personal. So I'll highlight those. And then I'm interested in two phases of the flight, landing and takeoff. So where these intersect are the frequency counts for the population. So for example, there were 849 accidents posted in this data set that occurred on landing for business purposes. And then for personal purposes, there were 11,144 accidents reported on landing, and so forth for the takeoff for both business and personal. So now we're ready to take a random sample, and I'm going to go back to the raw data. And in order to take a random sample, the first thing you want to do is to be sure that all of these columns are filtered. And then you're going to need to determine the sample size. And in order to do that, you're going to run a power analysis using G-power. We're using a chi-square test of association, but you're going to notice that G-power doesn't have that feature. It only has chi-square test for the goodness of fit for a power analysis. And for the purpose of your final assignment, that's plenty adequate, and we'll just go with that. So it's telling us that we need a sample size of 145. So I'm going to go back to the raw data set, and I'm going to highlight the first 146 rows. And it's 146 because the first row is the column label. So there's 146 rows, and I'm going to paste those into a fresh worksheet. Now I want to see, are there enough data when I took the random sample? So I highlighted these three columns and then click Data, Pivot Table. And if I'm looking at personal, for landing and takeoff, 23 and 20, that looks pretty good. But for business, there is only one accident reported for landing and 2 accidents reported at takeoff. So I'm going to have to increase the sample size. And I did that just by trial and error. And I came up with selecting 400 cases in order to give me enough data to meet the assumptions of the statistics. So here you can see that I have 400 cases selected. And among those, we can take the blank out of there. Among those, there were 8 accidents reported on landing for business and 15 on takeoff. For personal aircraft, there were 218 accidents reported and 159 on takeoff. Now, when I compute the chi-square, it tells me that the association is significant with the p-value equal to 0.03. And that means there is an association between the type of purpose of the aircraft, business or personal, and then the broad phase of flight, landing or takeoff. Now, how do you interpret this? For me, the easiest way is to compute the observed. That's the data that you have up here. Those are your observed values. And then to compute the expected values. And there is a formula for doing that. And I'll leave that up to you to do that calculation, although there are a variety of statistical calculators that will do those calculations for you. And one of them that I listed in our course resources indeed did that. So I have these kind of backwards. I shouldn't have, but I have takeoff and landing. So the expected value for takeoff was 110. However, we observed 15. So more than expected were observed for business. Now, for personal, we observed 218, but we only expected 213. That's pretty close. Now then, for business, for landing, we expected 13. We observed only 8. So here's the way that I would interpret this. And I would do it cell by cell. I would say that there was no difference between takeoff and landing for personal aircraft in terms of the number of accidents. And you can see here for personal aircraft, we had about as many accidents reported on landing as we did for takeoff. However, for business aircraft, it's a little bit different. And we expected only 10 business aircraft accidents, but observed 15. And similarly, for the takeoff phase, we observed 8, but we expected 13. So there were more accidents on takeoff for business purposes than expected by chance alone. And there were fewer accidents reported for landing than would have been expected by chance alone. And when you have a significant chi-square, 2 of these cells are going to be significantly larger than the other 2 in terms of relative size. And we're always going to make those comparisons between what we observed and then what we expected. And right there's the formula for calculating the standardized residuals. It's the observed minus the expected divided by the square root of the expected. But again, a lot of the statistical calculators will do that for you. So let's run through this again so that you can maybe now just pay attention to what I'm doing rather than taking notes. And this is a recording, so you can always go back to it. You're going to identify the variables. And in this data set, I believe they are all nominal data. There are no interval or ratio level data. There are no none that I could find. So we're only looking at frequencies. And so when you see the total of things, total fatal injuries, total serious, total minor, total uninjured, and so forth, those are frequency counts. And the only statistical test that we have studied in this course that uses only nominal data is chi-square. And in this example, we have two variables, purpose of flight and broad phase of flight. Therefore, a chi-square test that uses two variables is called the chi-square test of association. We computed a power analysis and determined that our minimum sample size needed to be 145. So we took a sample of 145, and we saw that we had very small observed frequencies for takeoff and landing. And we're going to need to increase that sample size. So I, through several iterations, landed on taking a sample size of 400. And you can see that it indeed increased the number of values for both business and personal, but I think for business it did get us to a point where we're not going to have any problems meeting the assumption of the statistics. These data were taken from one of the chi-square calculators that I listed in our resources, and these values here in parentheses are your expected values, and the values in brackets are called the chi-square cell values, and those probably cannot be interpreted directly. We would rather compute the standardized residuals. So we computed the chi-square test of association on these data here, and we found that the p-value was equal to 0.03, and that meant that it was statistically significant. Therefore, the relationship, or rather the association, between purpose of flight and the broad phase of flight was statistically significant. Now again, we're only using a subset of each of those two variables. Purpose meaning that we use business and personal, and the broad phase of flight, landing and takeoff. Because we couldn't have used all of them, you wouldn't have been able to meet the assumptions of your chi-square statistic, and it would have made it very difficult to understand.